Alright, well, welcome everybody. Welcome to another math problem. It's called solving rational equations. That's what it says. You don't believe me? Rational? Man, I wrote the wrong damn word. Man, that's... I do apologize, man. That ain't no rational equation right there. What you talking about, Mr. Miller? That's a radical sign. That's a radical sign. There it is. Now it's perfect. You see, I make mistakes and you're going to make mistakes too. It's all good. It's this byproduct of being this thing called human. You see, if I was afraid of making mistakes, I would be afraid of hitting record. Because every time I hit record, I always say to myself, man, I know I don't make a mistake. I'm not going to say it right. I'm going to confuse someone. I'm sure it's going to happen. But you just got to go with it, all right? So let's do this. We're trying to solve it. We want to know what X is. We want to know its value. And this is pretty abstract, so I'm looking back and I'm thinking to myself, I remember when Miss Johnson, when I was in 3rd grade, taught me how to solve for X when I first learned about the unknown. And I remember Miss Johnson said, you know, you always gotta have all those X's on one side of the equation. I remember that, so I say thank you, Miss Johnson. I say thank you. Well, I don't have that right now. I got an X there, and I don't like that. I don't want that. So I'm going to use the following property, and check this. This is good stuff right here. I don't know why I put it in a parenthesis. The square root of something squared is itself. Of course it is. Of course it is. Because it's a second root. You know why? Because really what this says... Oh wait, I'm going to make this a 1 and not a 2. What this says is that if you start at 1 and you want to get to x squared and you want to get there in 2 counts, what must you be counting by? And again, they're timesy counts. Well, you must be counting by times x. X times x is x squared, therefore the square root of x squared is x. Alright. Isn't that wonderful? And you might be saying, so Mr. Miller, yeah, that seems nice, Mr. Miller, that seems nice, but how does that help me here? What, do you want me to go square root and everything? I need an eraser. I don't have an infinite whiteboard. I wish I had an infinite whiteboard, I don't. So, we got what is that? We got a radical sign, we got no radical sign. I don't know why I rewrote that. Oh, I know why I rewrote it. I wanted the 2 outside the radical sign. So what we're going to do is here. We're going to square that. And this is equal to 7x plus 15. Holla back! Now I'm stoked, right? I'm stoked because the x is no longer in the radical, and that's what I wanted. You see a radical, you can destroy a radical by just squaring it. That's all you gotta do. But I'm missing something, right? There's something I haven't done, right? There's something just eating at your soul right now. Something feels wrong. There's only a few things you need to remember in math, and one of them is whatever you do to one side of the equation, well, you gotta do it to the other side of the equation as well. So I gotta square this side. Now I'm feeling good, feeling confident, feeling real good. So here we go. This is x plus 1 times x plus 1. You don't just distribute the 2. That's not a rule that works. You expand it out, now you got to multiply. Classically, we've called that foiling when we multiply these 2 binomials. Foiling is just a double distribute, so let's rock and roll. Well, let's rock with just a little bit of rolling. Just a little bit of rolling. I don't want to get crazy. I don't want to get too crazy. I'm going to do that over here too. I like to kind of work off to the side for some of my simplifications. So I'm going to do the double distribute. I'm going to take that x, I'm going to distribute it that way, and I get x squared plus 1x. Again, FOIL is a double distribute. So you take this term and you distribute it as well. You get plus 1x plus 1. Add your like terms. Holla. Over here, let's rewrite that. X squared plus 2x plus 1 is equal to 7x plus 15. I'll be feeling good right now. Because I can get all my x's on one side now. All I gotta do is come here and say, you know what? I want that x over there. That's what I want. And so how I'm gonna do is I'm gonna subtract it out. So I got myself a nice 0 and whatever that equals. Negative 5x. So this gives me x squared minus 5x plus 1 is equal to 15. This equation, its highest degree is 2. It's got a very special name. I'll let you think about it while I go get a pink marker. Its special name is, drum roll, there are no drummers. Its special name is quadratic. It's beautiful. The quadratic is beautiful. If we were to graph it, a quadratic function, it makes that beautiful shape. Okay? To solve a quadratic, we have some techniques. We have a toolbox. One of my favorite techniques is factoring. So I'm going to hope that I can factor this. To even attempt such a thing, I need it to equal 0. See the step there? Did you see it? Subtracted 15 from both sides. So this one I got to factor because this ain't a factoring video. I'm going to assume prior knowledge on this. And then I got to erase. I got to get back to the top of this board. But I'm going to go, this is x. So I need to multiply to get to here. So I like 2 and 7 because that's going to get me to 5. So minus 7 plus 2 equals 0. Again, kind of assume that you know how to do that. If you don't, I guess that's another video. That's another chapter, as we used to say when I was growing up. Now it's a new video. When I was growing up, I had a book and it was like, yo, it's a different chapter. If you're lucky, maybe it's a different book. And then you got to find your way to the library. Come on. Just hang with me a little bit. Alright, so if I multiply these two together and get 0, well, the only way that happens is if one of them equals 0. So x is equal to negative 2. And over here, we have x is equal to 7. So we got negative 2 and 7. And we're almost done. I'll say it again, we're almost done. You might be thinking to yourself, Mr. Miller, we're supposed to solve for x, and you just solved for x. So what are you trying to tell me we almost done? When we're solving radical equations, we always have to check our answer. And not just to see whether we made mistakes, because I remember when I first started solving things, I remember Miss Johnson, I remember her saying, check your answer to make sure you didn't make a mistake. You see, now we got to check our answer because of this thing called an extraneous solution. We got this thing that just happens. Watch. I'll check my answer right here. You thought I was going to drop that. You didn't see nothing. All right. First, I'm going to plug in 7 and see what happens. Let's get a little separation. And I got 7 plus 1. I'm going to go to the original equation. So forget that original equation is not squared, right? Was the square root of 7 times 7. Okay, so 7 times 7 plus 15. So 8 is equal to the square root of 49 plus 15, which is 64. And 8 is equal to 8. So 7 is a solution. All right. Let's go think about negative 2. Now this one, we don't throw away the negative x's. That's not a rule. We don't do that. We check it. This one is going to fail, by the way. We always see that, but it's not just because it's negative that it fails. Sometimes negative is correct. So So here we go. Negative 2 plus 1 is equal to the square root of 7 times negative 2 plus 15. So negative 1 is equal to the square root. That's negative 14 plus 15 is positive 1. And that is not a true statement, because the square root of 1 is 1. These two are not equal to each other. And so that gets the axe, gets the hammer. And if you give me one more minute of your time, I will tell you briefly why extraneous solutions happen. So let's remove this art. Well, actually, let me put it over here. Let me put it right over here. I'll just squeeze on in here. Squeeze on in there. Here's an equation. That's a beautiful equation. What does it say? It says x is equal to 3. Look what happens if we square this equation. I don't like this pen. This pen isn't bright enough. It ain't good enough for you. Ain't good enough for me either. Alright, so what we're going to do is we're going to square it. That gives us x squared is equal to 9. And now we're going to solve by square rooting, and we get x is equal to plus or minus 3. Notice there's two answers there. There's x equals positive 3 and x equals minus 3. But minus 3 is not a solution to the original equation. Look at my original equation. It's just x equals 3. Well, negative 3 doesn't equal 3. And so this is an extraneous solution. So extraneous solutions just kind of happen when we start squaring things and square rooting things. So we always got to check our answer. And we always got to be happy, and we can never be afraid of failure. And I'm sorry if I failed more than once here. I don't think so. I think the math worked out for me. It's a sunny day. I hope it's a nice one for you. Take care.